A very good afternoon to one and all present over here. So I welcome you all to the third session of day 2 of our 1 week FDP program. So it's my pleasure to introduce Dr. Lochan Jolly to all of you. Dr. Lochan is working as a professor and as a dean, student and staff welfare completed her PhD in electronics and telecommunications from SNDT University, Mumbai. She is also Chair, Educational Activities Committee, EAC for IEEE Bombay section. She has 20 years of teaching experience. Her area of specializations are microelectronics and VLSI, optical communication, satellite communication. She has received Best Employee Award. She also has received Appreciation Award for STEM Initiative by R2IW in World IP Day. Also, an Appreciation Award for STEM Workshops by Rotary Club. An Appreciation Award for FOSSI IIT Bombay for contribution to Scilab Textbook Companion and Lab Migration Project in FOSSI Symposium. She has published many research papers and international level conferences and journals. She has started STEM initiative with the name Tech World to spread awareness about technology and development of science temperament in students right from the school. She has received grants from University of Mumbai, DST, IEDT, ICT, etc. So I request Lochan ma'am to share her thoughts with us and take over the session, please.
Thank you, Megha. So good afternoon, everyone. I welcome you all to this session on hands-on using LabVIEW. So just few slides I have kept it before I directly go to the LabVIEW and we start doing some experimentations, I would say, with using LabVIEW on the major objective that I have set for this particular session is only one is interaction of, because when we talk about smart systems, cloud makes a very important part, whether it's about keeping the data analysis and able to access the data from remote locations. So the only objective for today that I have kept it is using LabVIEW, we are able to access the cloud, that is store the data on the cloud, and at a remote location, how we are able to access the data from the cloud using LabVIEW. So LabVIEW is Laboratory Virtual Instrument Engineering Workbench, and it does not need any kind of programming language, but what we call it as a graphical programming language, where you have simply the controls to drag and drop and make an interconnections as per the data flow, and you can actually not only see what will happen to your data as a part of your process, but also you can do the pre and post processing of the data. So LabVIEW relies on graphical symbols rather than the text languages. So there will be no language involved. It is identifying your instruments or your components that you require for making your system and just using those to make your program and making the data flow connections. So the LabVIEW programs are called as virtual instruments because they imitate the actual instruments, like how oscilloscope will be behaving, or how your temperature sensor would be behaving, or any sensor that you are using, and how the readings would be visible, and how you can play with your instrument. I would say the way we do it with an actual instrument, similarly we can do it as even testing for the condition where you may experience a breakdown also in a system, that even can be simulated. So the main program functions and the subroutines are popular like any other language. We will find here if then else, we'll find case structures, we'll find for loop, these functions are available like any language. We have to apply the logic along with the design of the process that you have designed. This I have simply taken for a mechanical example as how your work will look like controls, and not only giving the inputs, but also reading the values at different positions, so that you are continuously updating the data and if required, storing the data as well. So in LabVIEW, what we create is a virtual instrument for data acquisition. LabVIEW, the virtual instrument allows your computer screen to act as an actual instrument with characteristics tailored to your particular need. Here, very important point is LabVIEW will not only be allowing you or giving you a platform to simulate your system that you want to design, but it also helps you to integrate maybe a hardware with your system and through your system to the cloud, and basically remotely being able to access the instrument which is at any other remote location. So it's like integration. It helps us not only acting as an independent service to you, but also integrating the way, if I talk about what Niket sir taught in the second session about Tesla boards. So if you have some hardware which is like a sensor IoT node, which is actually acquiring the data maybe at certain instant of time. So through this program, without using any bigger hardware, I would say that through this system, you can simply take the do the data acquisition, store it in your system, or store it on the cloud and then access it. So this virtual instrument has three parts when you are making it. The first is the front panel, then the block diagram where we make the interconnection. So whatever we have it on the front panel is visible also on the your block diagram window, but there the data flow and the logic that you are using for processing of your data, everything is built on your block diagram window using your connectors, the wires, or whatever components you're using. So this is the one which example as I showed you. It's a front panel. So it shows you how a user will be interacting with it. Maybe the input that you will be providing, the sensor data that you will be providing directly, you can give it here, or how the output will look like, whether I'm sensing the temperature after say every 1 hour from my system or after every 10 minutes from my system. So accordingly, it will be updating and visible to the user as if he is looking at a actual system. And at the back, as I told you, all your logic, whatever, like this is some structure that we are using, it's a for loop that I'm using, or whether I'm using some other case structure or a control panel. So all that is there on your back, you can say block diagram, and there you are developing all your logic. How you are basically, I would say that all your mathematical model equations. Like if you are representing a diode, if I take an example, the current is proportional to the exponential of the voltage. So I is equal to I naught e to power v upon eta vt is a simple expression. So that's a mathematical model for representing a diode. And if I want to see that what is an impact of temperature, I know there is a term of temperature Vt in it, and I can even model that. So all those mathematical model equations for any system that you are defining, they are done all at a back end. So this block diagram window where we make all our equations, or basically representing the mathematical model of the system, and the front panel displays how the system output will vary with the changes in the input or with the input acquired from maybe any hardware attached to your system. So this was just a brief introduction which I wanted to give you an idea. So I would directly, I hope all of you have been, my screen is visible now?
Yes, ma'am.
Yeah. So all of you have downloaded a LabVIEW. So you will see this LabVIEW symbol on your system. So I would just request you to double click on it. And on the top, you will see, I will just open one, and on the top, you will see a file. Whenever you're opening a new system, a file. And in that, just click on new VI. And you will get the two windows. One is a front panel and the other is a block diagram. So I'll just maximize it. Control E. By Control E, we can simply flip between the two windows. So this is the front panel where we can have all our components, whatever. I'll tell you how to do it, just to tell you. And this is block diagram, as you see, where we can make all our logic. So just let me know whether you are able to open it or not. Once you open it, you just get a screen. On that, you have on the top left corner, there's a file. Click on it and click on New VI, New Virtual Instrument. So let me just, for taking the say first simple component, I say a temperature sensor, which will be giving me an input temperature. Here I'm assuming that I'm using it as a input and I want to simply display it. So I just take a right click. You will get all the controls. So there, here is what where you get all your numeric, Boolean, as you can see, the string, array, all type of data that we'll be requiring is available here. So presently, I'm just taking a simple example of numeric. I take a knob. You can even take any slider. It will give you a numeric value. It's just a representation, how you want your instrument to look to the user when it's visible to them. So I just take a knob and I name it as temperature. We can have always the range changed. Say I want to make it 100. So it will immediately change and I can set the range. I just press Controls E and you can see the block is available here, right? So suppose I want to take a decision depending upon my input that it is high or it is low. Okay, so let me say that I define the conditions that when temperature is less than 30, I call it as low. When it is between 31 and say 100, it is say normal. And when the temperature is greater than 101, I would say equal to I call it as high. Right, so this is a simple logic that we want to use is 3 conditions, 3 cases depending upon the value of my temperature. So like normally we do the programming, since I know there are 3 defined cases, I'll go for a structure that's a case or a small case structure. So what we have to do for that is I'll just do a right click. And in that, you can see the functions. Here you have, in the front panel, the control panels were available. In the block diagram, you have directly the functions available. In the functions, you can see, as I was telling, you have all your for loop, like normal programming, all structures are available. I take it as a case structure because right now I have the 3 cases defined. Ideally, by default, it has a true or a false value. Once I connect this term, which is going to control it, since it's numeric, you can see the values have changed. It will take some default value, or I always have an option to add the cases. So what we say is has to be less than 30. So to write less than 30, I just write ... 30. That defines my case 1. Then I have another case. So it is between, I can just edit. Kuch bhi, no programming, I'm just editing. It is between 31 to 100. Okay. And in case now the cases are complete, I can just right click and you can see that add a case after, right? So since I had 3 cases, by default, it is giving me 2 cases. I can always add a case. So it has already taken 101. I'll just say greater than 100. And just click it. Can you see the 3 cases have been made till 30, 31 to 100, 101 and beyond. So all the 3 conditions are displayed. Is it okay? Is it doable? Okay. So now how do I, yeah, thank you. So now how do I check whether it is low, neutral or high? So what I'll do is I'll simply take, normally how do I do in a system? I'll use LEDs, right? When LED to represent low, LED to represent normal, LED to represent high. And when it is low, my low LED will glow. When it is normal, my normal LED will glow. And when it is high, my high LED will glow, right? So this is a simple logic that I can build. So what I do is either I can go to the front panel and add the 3 LEDs from the Boolean. So I can just select the shape as I want. I just take the shape as, say it is, I name it as, double click and you can edit it, low, low. I can always increase the size of my component, font size, always I can do, as you can see, this is selected. I can always play with the size, make it more bold, style, all that can be done. Yeah, Mr. Satish Kumar, you have raised a hand. You can please unmute, or is it by mistake? Yes, yes. You can always, actually units in a sense, you can actually say whether the temperature is directly in Kelvin or whatever. You can always define the units, and accordingly when you are using in your mathematical model, you'll be taking the units that you have assumed. Like normally when I'm taking a wavelength in my practical. So I know the wavelength is in nanometer. So I have to take that 10 to power of my, I may write it in my front panel that this wavelength is in nanometer, but when I'm modeling, I have to see that I take care of that 10 to power of -9 factor, right? So it's all defined by you. Anything else? Thank you. So like this, I can copy paste. Yeah. Control C and Control V works here very well. Okay, I can just name them as, okay, so my 3 LEDs are there. I just go here. I just, for my convenience, I arrange them. I'll just clear this window. Now what I have to do is, when this is in the range, say for every case I have to define, right? When it is this 31, what it is, this is true, right? For logic Boolean, I have to give the input as 1 or true or false. So what I do is I just right click and go to, yeah, I go to the Boolean and take a true constant. Okay, I have to make my logic true or false depending upon my condition. So I just take it and connect it with my, okay. When it is say 1, what I have to do is, again I have to 101 above, go to the Boolean, right? And when it is the third condition less than 30, again I have to, right? Okay, but still this small circuit is incomplete. How do I know that? Is on the top left corner. Can you see this arrow is broken? This arrow broken says that the circuit is incomplete and it will not be able to simulate it. Means something we haven't completed. What we haven't completed is these nodes are there, the circuit is there, but no connections are there. Therefore, it is giving you a break in a circuit, that is, it is incomplete and we need to complete the logic. So what I'll do is I'll just again go to the Boolean sorry, it has to be false. I can either make true false or directly select a false constant. I repeat this for the remaining two cases. I've simply used the copy paste so that I don't have to go and again select it. As soon as you go to any node, this wire will automatically appear so that you can make any connections or any data flow. It can be easily shown through these wires. So can you now see on the top left corner that arrow is no more broken? This simply shows me that the circuit is complete and ready to simulate. Any time before simulation, please check for this arrow, which shows that the logic is incomplete or we need to redo the thing so that, or check our logic that we have missed on some points, and until and unless it is corrected, it is not going to simulate. Yes, everyone, are you with me? Can we proceed? Thank you. Now, let's go to front panel and see the output. How to run it is, this is a single run, that is for this particular condition what it is, it will run. And the second one is called as run continuously. Once I click on this, if I continuously keep on changing my input, my output will continuously change without requirement of running it again and again. So I'll just demonstrate it. I just click it. Presently it's 0, you know, for less value it is 0. Till 30 it is 0. The moment I go beyond 30, can you see the normal is high? I don't have a scope for greater than 101. I'll just make this correction and make it 200 and run it. So normal, can you see high? So like the way it's like playing with your instrument. As the temperature is changing, the indicators are changing. Yes, everyone? Now point is I have this data, right? Now my point is I am able to do the processing at my remote end, but my requirement is I need to upload this data on my cloud. So I'll just look into, I have not used any logic for developing this temperature. I'm assuming it's an independent system and only a temperature sensor. You can have this for a full system for which you will have a mathematical model, right? And that model, that equation can be easily simulated, or I would say easily represented in your block diagram, because it has not only got your blocks, but also can you see the mathematics. All operation, name any operation, all operation, any kind of mathematical equation that you are using to represent your system can be represented here with the use of all operators given in it. So now let's come to, I have this temperature, which is the data from a sensor, and I want to upload it on a cloud. Before we go on a cloud, let's set up our channel on ThinkSpeak. So all of us can just go, I have already logged into, what we can do is go to the Google ThinkSpeak. So this IoT Analytics ThinkSpeak, just click on it. It will ask you to create your login. Here on the top, it will ask you for sign in. Using your any Gmail account or your account, you can always log in. So you can create your login. As soon as you create your login, it will give you an option where you will not have any channels. I have some channels already existing. For free version, we get 4 channels for us. So if I want to say create a new channel, it will help me to create a new channel. So I name it as, now what all data I want to upload, right? Say if I have only temperature, one field. If I say I want to upload 2 data, maybe temperature and pressure, or maybe a heart rate. If it's a medical operator, it can be a heart rate, something. So let me take it as pressure. So I've just made 2 channels. Okay, you can have multiple. As you can see, you can have the number of sensors you have or number of data you want to upload. You can always tick on this and activate it so that the data can be uploaded. Whenever you say the data right now is to be uploaded on temperature, it will upload on temperature channel. When you say on field pressure, it will upload on. Means definitely we have a identifier as where the data is going, to which channel it is going, to which parameter it is going. All that is there for every channel when you are defined. Now, how do we actually say that once it is done? Say I'm okay with these 2 parameters only. I say save channel. So my channel, as you can see, IEEE FDP is created. Presently, the status is no data because I haven't connected it anywhere. As I was saying that every channel will have a unique identifier. So how do we get those identifier? It is through the API key. API key will have it for the write and the read, right? So that's a read request when I want to, API request when I want to write on a channel. This is the request URL that I'll be able to write it. And when I want to read from a channel, this is my request URL. And I would say that another important parameter when we go to API keys is the write key. The unique numbers are there, and we can always use this in case we are using some kind of concatenation of the strings, so that we can not only have a unique channel. Once I say that I use this URL, actually you are fixing the channel where the data will be uploaded. In case I want my data to be on my channel and some XYZ channel. So depending upon when I want it to come to my channel or somebody else's channel, I can always use these keys which are unique to the channel for identifying and uploading the data on that particular channel. So this is a simple task of making your channel and identifying the URLs which we'll be using to write and read. I just copy this part and keep it because first task is to write. I just copy it. Now I'll go to my Now, how do I upload a data? It's a very simple task because LabVIEW has data communication channel. So what I do is right click. Can you see data communication? In data communication, there is protocols. In protocols, HTTP client, just pin this. You have open handle, get handle, and close handle. Okay, I just close it. So I just make the connections. Now this is a communication channel is already set, but what I want to do is I want to upload the data that I have set it. So what I do is just click on this. Can you see the first pink icon? It's written as URL. Is it visible on my screen when I click it? So it's here I have to provide the URL where I want to. Here is the URL where I want to provide the data. Right now, how do I write the data? I have to simply have a constant where I'll be able to write the data. So what you can do is right click on this pink icon, just go and right click and go to create a constant. It's a constant right now for us, right? So a constant is created. In this, I just copy paste my URL, it's nothing but the same URL. Now this is the API key and field 1. Can you see here? It's written field 1. By default, your right address, the URL we got, it's field 1 is equal to 0. Means the data is 0. Okay, so before I run, I just want to make it say 25 so that we will be able to see whether we are able to upload or not. And just remember, right now I have used field 1. And right now I'm not touching this part. We'll see how to get a specific data. First, let us see whether we are able to upload the data on the channel. So I just run it and I'll open my cloud. Can you see? Presently, it is exactly 3.9. At 3.9, the data is 25. And I'll again go and say I make it as, I have to stop it and make it say 100. I again run it. Can you see? The data has changed from 25 to 100. But this is only in field 1. At a time, it is able to upload through one channel. It is able to upload to one cloud. Now let's see that whether I'm able to, how to upload it on the second cloud. Definitely. Yes, Purnima. Purnima, you want to ask something? By mistake. Okay. So now if I say I want to upload the data on channel 2, just field 1 is to be replaced by 2. Again, let's run it and see whether 100 is getting uploaded on our cloud. So after every few seconds, it's fetching the data. See, can you see? It's 100 on field 2. Okay. Again, I'll make it as, say, did I run it? Yeah. 102. This is the value is 10. So right now, with this small setup of our open handle, get handle, and close handle, we are able to establish a channel. But is it dynamic, or every time I have to actually go check my field and make it and change the data, right? So we need to make it more dynamic. So that's just an arrangement of breaking this string into some parts so that I can actually be able to upload the data, required data, any dynamic data that I have on my channel. For that, we need we'll break this whole string into few parts and try and add our identifiers that we'll be uploading the specific data as required from different sources. So first thing is, as I told you, we don't want, say, our channel to be fixed. For that, this API key has to be changed. We want that we should have a control of which field we want to upload the data and also what data we want to upload it. Okay. So what I do is, for that, we'll just have, sorry, we need to close it. Just what we'll do is we'll go to the string. So it's like breaking your string into parts and then adding it. So I just use concatenate string. And in this, I am dividing the string into two parts. So the upper part, I just say create a constant, and second lower part also, I say create a constant. Okay. Now, first part, as you can see, I'm just taking from here only till thingspeak.com. It's a fixed part. From update, it's like we will want to make it dynamic. I just say I'll put this part, right, till this. From update, what I have to do is, this is a string. Okay, I want to make it like I should be entering it. So for that, I just write it at %s. This is field. Again, it is an integer, whether it's 1 or 2, I just write %d. And okay, so I'm just taking till 2 decimals. Is my screen visible, or can you see this? What changes I have done? I'll just type here what was there, which I have simply broken it. This was our right channel. So till thingspeak.com, we have taken it as part 1. Yeah, very visible. Okay. And from this part, I have replaced this API key by percentages because I know there is a string. One I have replaced by percentage D, that's an integer. And for data, it could be a floating data also. So till 2 decimal for representing it, I have written it as percentage 0.2F. So this is a change that I have done and trying to concatenate is making it into a string. Now, once I have made it into a string, I need to have a provision to add these data that I want to have it. For that, before I proceed, I need to go to the front panel, and along with the temperature, the other input that I want is the field, right? I want to know whether it is 1 or 0. If I want to have this, then let me say, can you see the field is also there available for me? Now what we have to do is we have to add them, format into a string. We are formatting. So I just take this. This is what is the format that I'm giving it as an input. So format string. The first one is the API key. So again, I need to have a string control. So this, I take it as API key. Okay. Here I'll be putting up the key. So the first is a string. So as per my data, then I need second field that is I need the field number. Just slightly drag it. I connect this field to give it because that's the next data that I want. The third is the data that I want, which is say temperature. Again, I pull it a little down. I get the third point input 3. Okay, I'll just delete this because now we have made this part again. Okay, now once this is made, this is the resulting string. Can you see? I can just take this and put it into the URL, right? Okay, so let's see what it is presently. Let me go to presently. I can make this as counter. I have increased it to 1. And the temperature right now is, you can always add your visible is say digital display so that I know what is the value that I want to see. Oh, sorry, I have not put the API key. I'll go to the cloud and copy the API key. This is read key, write key. Can you see the data 119 is uploaded now? Now let's see whether when I'm varying to field 2 and say now making the data, can you see 775.35? Let's check whether something is happening to field 2. See, what is the data? 175.35. So not only we could upload the data, but make your channel dynamic. Now it's not necessarily that only I will be able to upload it on my channel, the data. If some other channel is there, I can always change the API key, and on that channel, I can always upload the data. Is there any doubt on uploading a data on the cloud? Yes.
Yes, madam. For field 2, there would be a temperature na, rather than pressure. Or you can
Right now,
change the pressure.
yeah, that you can always change, sir. यहाँ पे लॉजिक लगाएंगे, राइट? I'll tell you. ये केस स्ट्रक्चर बनाने का रीजन ही ये था कि if I use one counter, how can I do? You can always. I just did not have. Let me check. Tell you. I can always have this one more. Say this is pressure. Okay, now I have two inputs. At a time, as I said, you can always have one. So you need to, ये line तो एक ही रहेगी sir. आप logic design कर सकते हैं. If it is one, temperature should be, or gate आप use कर सकते हैं. You can use a multiplier, you can use it and have an AND gate. तो आप यहाँ पे logic gates use करके you can always see that I can use pressure, when to give pressure. यहाँ पे logic design करेंगे, यहाँ input तो एक ही रहेगा sir. Right? यहाँ पे
Okay.
हम काउंटर लगा सकते हैं. I can use a case structure जिसमें field रहेगा. For one, my output is temperature. For two, my output is pressure, and that output is getting connected. Here I'll not put two. Okay. Input तो एक ही रहेगा sir. Whatever be the dynamics of this. Only thing is you need to design your logic prior to this. Okay, sir.
Yes, okay, ma'am.
Yeah, thank you. Okay. So I hope this uploading on the cloud, is it clear? I just use this to tell you the power of taking the decisions and logic, and you can always see that you can use any other logic or mathematical model. अभी तो हमने directly knobs पे input लिया. Is it okay? Now coming to the next part. Again, now our task is we have uploaded the data on the cloud, but we should be able to fetch the data from the cloud. Okay. For fetching the data also, we use the same channel, communication channel we will use. I just take it again, data communication, protocols, HTTP client, open, get and close. Okay. Now what I have to do is I need to put the URL. Now URL is what? Is it read or write? I have to read it from the cloud. So the URL that I'll take it from the channel is the read one. So right click, create a constant, the way we did it. And now we'll go to the channel, API keys. Now on the right side of this block of get handle, can you see the upper one is a header and the lower one is the body. Header will have the address and the body will have the data that you want to take. So for seeing, since our task is to read what is the data, I'll just right click on this and create an indicator. Right, I want to see what is there and this. Okay, so right now what is my task? I know the channel address and I want to see what is the data there. I'll go here and you see the body is auto. Even if I don't have anything on my front channel, whatever logic I develop in the block diagram, accordingly my front panel gets created. So what I'll do is I'll just run it. I'll just stop it and show you. So see, I have all the data and the last one, do you remember what we uploaded was 175.35, that was in field 2. So field 1, field 2, all the data gets on your screen. But this is, I have to go and search where is my data, right? Reading is okay, I know, so I know field 1 ka data kya hai, field 2 ka data kya hai. But now what we have to do is, this was a simple task, the data is fetched from which channel, all the description, what is my location, every description is there. One is temperature, field 2 is pressure, all descriptions are there. But I'm only interested in this number being displayed, right? So that I know that this is the data that I'm getting. The simple logic that is used for getting the exact data is using the delimiters. We know using the delimiters, we'll be able to identify the location. And first thing is we convert this string into an array. And then using the delimiters, we go to the location where our data is there and simply fetch it and display it. Okay, so for displaying, let's see, this time let us use a graph. So okay, and I can even, for more visibility of the number, since we want the number, we can use a gauge. These are the two things that will display my output, but the first and the most important task is converting the string into an array using the delimiters. So I'll just see what are the delimiters that we have to see. Can you see the curly brackets, the colons, and the double quotes? Okay, so just from this data that I have, that we say that the closing curly brackets, because this is the final one where I'm getting the data. So the closing brackets, the colons, and the double quotes is what we'll be using as a delimiters by converting it into a string. So for that, we need to go to the string. So the first thing is we need to convert this string into an array. So this is my data. There are two constants that I'm putting. I'll just copy paste from here so that the time is saved in finding out just this logic. So once we have the spreadsheet, the string to an array converter, in this, the delimiter that we are using, the first one is a closing curly bracket. I'll just show you the data where we had the data closing curly bracket. So if I see the data, the first closing bracket is this, and the second closing bracket is this, and after that the last part is coming. So this arrangement is you see as the number, the closing bracket, and an index array, that is for the row and the column. So which one I'm taking is after the second, the data. So if I show you what is there, can you see from the portion, because of this delimiter that we have used, from the portion created to 17.25, I'll just run it, the data. Yeah, 17.35, can you see from here to here it has been copied. Means is not the output of it. Now the second delimiter that we use is a colon. So this arrangement which I'm trying to show is just to extract the data. So we'll not spend much time on it, and that is why I've kept it ready. Right. So what we have done is same setting. The colon I have used. Now it's the fifth colon. After that, the data that I want, we can see what is the output that we are getting. And lastly, since the data is in double quotes, so that is in, as you can see, double quotes mein data kahan pe aapka, just after the first location of the double quotes. So this is the data 26.86. So now, finally, what we have to do is, once we have done all the process, we have to convert, because once we want to display it on the waveform and the gauge, they take the numeric data. That is why we have to use this conversion of string to the number. Again, that is available in our number and string conversion. So directly we have string to the number. All array operations that we do, it's an indexing that we are doing. It's available in array. So once we have this, we can simply try to run this. I think I'll have to change the API key because I have made a new channel. This is a new channel that I have fed it. Let's see whether we are able to get the output. So right now we cannot see any output. For this, we have to run our other program also where we were writing it on the cloud. So I just run it. Presently, as we see, the data is, say, I keep it as new value 97. And let's see what happens on the cloud. Yeah, the value has changed. Now let's see whether we are able to see it here. Sorry, not here. The data is visible here, 97.5, but on the gauge, it's not visible. Let me check. Should see here. Okay. Yeah. Can you see? The data is now coming and it's even visible on the gauge. Okay. So I can actually right now stop it and add a visible display. So 184.54 was what we have, and that is the same value we are able to. So we not only could upload the data on the cloud, but also fetch it. This can be like, as I told you, if you have the channel, all details, and if you give the rights, like your private key to the any user which is remotely located, it can be easily taken and that data can be accessed remotely from any location. So this process of adding a conversion of string to array index array, this was only just to have a better view of the data rather than just the body where we were trying to search the data. These arrangements is for making the data more prominent, and maybe if you want to use it as like this data. Suppose, as I was saying, the decision which you took it at your, if I say, this decision I want not here. I may give the input here and I want to take this decision remotely on this particular data. I'll just so I now don't want this input temperature because temperature is what I'm fetching. Now this decision as we were doing initially at our location to find out what is the temperature, whether anything means remotely, if somebody is there, he will get any kind of alarms. So let's see whether we are able to see anything on our, yeah, it is visible, just the screen since, can you see, since it's greater than, it's high, even at the remote location, you are taking the decision. So this logic which you developed initially can be like at a remote location, whether if I say most of the applications which we develop, say for a health application where you are talking about some kind of critical parameters, the sensors that you have, you can have it at a remote location and their data can be accessed at your locations, and you can always take the decisions also. So the decision will not be dependent you can develop this logic. So with this program or your setup or the process that you have prepared, you will be able to access the data and so not only access it, but process it. So any doubt in this? Yeah. So everyone, I would request you should also try, because this does not require much of programming. It's just a drag and drop. And anything that if you say, I want to, like where I have used as personally while teaching it is while taking my courses on optical communication, where we have modeling of all process, whether it is the losses, whether it is like noise, everything we could simulate and clearly see its impact, whether it's an attenuation calculation or whether it is compensation that we provide to rectify anything in our system. All that could be done. The other point where I have used is in our IoT laboratories that we have used to demonstrate, and even we have used it like, as I was saying, Niket sir was talking about the Tesla board. We have even had used our simple Arduino boards, which had some sensors. And instead of taking that temperature block as an input directly from the system, we could have our serial data communication where we could fetch that data from the Arduino board and then do this processing, upload it on the cloud. All that could be easily done. So that is what I would say is the beauty and the strength of this particular tool, that especially during pandemic, when the students had no access to the instruments, they were finding that this was a tool which was very made the things very interactive, because for any condition, if I say, simply they were supposed to set the input and see what is the response on the whatever. It's even does help you to do your signal analysis. Everything could be done, and they themselves shared that this gave them that feel of being able to play with the instrument, which was missing when we were using only mathematical equations to uh, uh, basically model a system or simulate a system, rather than using this. And here also definitely they were modeling. Knowing the mathematical equation of a system is actually mandatory wherever you want to simulate your system. So if there are any doubts,
Ma'am, can we get this VI for practice?
Yes, yes, sir. So Sujata ma'am has actually shared that link for downloading. So you can always download. Even you can go to the NI instrument site and ask for the student version. They give you. You can just write a mail. They give you the latest student version also. So the one which we have shared with you is 2017. You can always get 2020, 21. The new versions are always coming.
No, ma'am, VI. I'm talking about VI. LabVIEW I have.
Yeah, sir,
VI.
yeah, .vi. The file can be easily shared, sir.
Yes, yes. Because
Yes.
I will try with this API.
Yeah, I'll definitely share with the coordinators. They can share it in the group. You can always download it and use it.
Yes, ma'am. Thank you.
Anything else? You want me to share it? Sujata, I'll share with you this VI file. So you can post it in the group.
Okay.
Okay. So that's it from my side.
Thank you very much, ma'am. Thank you for a hands-on session at this point in time when already people were half asleep after lunch, but while doing or practicing with you, they were enjoying the session. Thank you very much, ma'am.